I want to talk about the week that everything changed. The week that everything changed here started on March 17th. I actually can count on one hand the number of places outside of my home I've been inside of since then. And I don't know what week it was, but around the world, there was a week where everything shut down. And on that week, we also had a call to action for us folks that were technology experts, because we couldn't just go home. We had to help everybody else go home. We had to enable work from school, or school from home, work from home. We had maybe 3 days, not too long. And everything had to happen in that very short period of time. We had to deal with equipment. We had to deal with software tools. We didn't actually know about Zoom at the time. We had to find the right licenses. We had to make sure everybody at home had internet access. We had to figure out training for techniques that people were supposed to use, like professors teaching from a new teaching tool. We had to provide support. We had to worry a lot about security. We had to figure out how to get teams to communicate. Every single person, 3 days, that was it. That's all we had. And it wasn't like you could say, nah, I don't want to do that. Okay, we had to make it happen. And so around the globe, what we saw was, the impossible happened. And it happened because, first of all, countries closed, borders closed, travel suppliers had to get people home. My granddaughter got almost stranded in Morocco. She managed to catch one of the last flights out, and people that got left behind waited for weeks to leave. Professors and kindergarten teachers had to learn how to teach online. I have a granddaughter who's a first grader, and at that time she was in kindergarten, and it was quite interesting to see her learn online. Stores that remained open, they moved to contactless or pickup delivery. In our neighborhood right now, every single store allows me to order online and drive up and connect with the people inside, and they bring my order out to my car. And we learned about Zoom. We didn't actually know very much about it before then. It existed, but suddenly it had to scale. And the way that this happened was teams got thrown together really fast. And they were whole teams that could solve a problem, and they were thrown at a problem. If you were in a university, I gave a talk in a university, and the CIO was thanking everybody in the technology area for all of the work they did, because they joined teams that figured out how to get the professors' stuff online. They figured out how to get internet access points where people were. There were just amazing things had to happen. And the software engineers joined all of the other people. If you were in a store and your store had to switch to online ordering and contactless pickup, and you were associated with that store, you needed to get in touch with the people who were going to figure out the logistics inside of the store, where people were going to park, how to get the inventory properly online, how to notify the shoppers if the stuff isn't in stock, all kinds of stuff. There were procurement experts, there was call center staff, and whatever task it was that we were trying to figure out how to do and do remotely, everybody knew what success looked like. Everybody knew when it was working. There was no question what the goal was. And it had to be done fast, and you couldn't fail. You couldn't say, it's too short of a time. No, we can't figure out how to do that. You had to do something, and you had to do it by a deadline that wasn't going to move. And there were a whole lot of digital transformations around the world that took less than a week, and suddenly the whole company was digital. What we saw in our neighborhood was really interesting. There was all of the grocery stores had a small ability for about 1 or 2% of their customers to allow ordering online, driving up, calling a number, and picking up stuff. But when all of a sudden everybody started using it, they got swamped. They had order slots, and the order slots filled up so fast that the first order slot you could get was like 2 or 3 weeks away. One store near me was unable to get the changes that you put to your order to the store before they actually filled your order. And what I saw was some stores were way faster at solving the problems that cropped up with their systems and getting everything to work for customers and for the store staff. Some were a lot better than others. And I called one store that was not able to allow me to make changes. And it was 2 or 3 weeks after everything started. And they said, well, yeah, we have contacted our software contractor, but they haven't had time to help us yet. And you know what? That wasn't a good enough answer, because the other store, the one I use exclusively now, had internal people that dove in and helped the other people to solve the problem right away. They were able to put a whole team together, and everybody involved got together and figured out how to solve the problem. I had an inventory problem, and I called up and I actually talked to the person that could change the inventory problem. At first, I was contacted after every order asking, what can we do better? And whatever I said, it turned out they tended to do that thing within a week. So in this case, when it was all about how do we get everybody home and get the technology in place, it wasn't about software. It was about providing the technology infrastructure to do something that had nothing to do with software. The people that were home were solving much bigger problems than software problems. And the teams we were on were not about figuring out how to deliver this or that capability. They were about making sure that the drive-up system worked, or the technology worked for online conference calls, or whatever it was. And the other thing is, we learned, once we went home, we learned a lot about each other. So we learned that our coworkers are real people. They had children and dogs. These are my grandchildren and their dog, and their father, my son, and his workspace at home. There are guitars and bikes on the wall we saw, and we learned empathy. We learned that those people that we work with at our office they're real people. They're not like just the corporate persona we see every day. They actually have the same kinds of families and problems that other people have. And we learned about management. So we learned that supervisors couldn't monitor activity anymore. And so how do you deal with the fact that you can't see people when they come into work and you're not sure how long they're working? Well, most of the time, responsibility replaced close supervision. Do your best, figure out how to make the problem solved. Sometimes, however, there was a whole lot of keeping track. The thing that made a big move at that point in time in March was workforce optimization software, so that your supervisor could look in on exactly the number of hours you were at the computer, what pieces of software you were in, a whole different level of, monitoring. I wanted to call out a really interesting article by Barry O'Reilly called "Why Your Company Isn't Profiting from Remote Productivity." And there's the link at the bottom of this slide. And in it, he says, we have to relearn management for a distributed world. We have to figure out how to create a strong connection between the work effort and customer satisfaction, so that when you do something, you can see the customer results. Because the productivity gains from the work at home, they vary depending upon what you define as success. So if you say, has working from home been successful? The question is, what do you mean? Do you mean productivity? Do you mean you got more stuff done? Well, at first, in fact, there was more work. There was more output done because it was so novel. But after time, and as time moved on, the productivity fell. And we saw this in an awful lot of reports from an awful lot of companies. But at the same time, if you define success differently, if you define success as delighted customers, then what we saw is that teams that had responsibility for customer satisfaction, not responsibility for getting stuff done, but responsibility for making sure the customer's problem was solved. Absolutely, the working from home was really just as successful as if they were in the office. But if teams had proxies, so what do I mean by a proxy? There are two kinds of proxies. One are proxy metrics, like cost, schedule, scope. Those are project metrics, but they don't tell you whether or not the customer is satisfied. That's a proxy metric. Or there are proxy people, intermediaries between the people doing the work and the customer receiving the benefit. And we have a lot of proxies in software too. And we have proxies called the business. The business is almost always a proxy between the team and the customer. We often implement the product owner role in Scrum as it's traditionally defined, which is a proxy. So we have to think about why we can't get the teams directly engaged in making sure the customers have what they need, as opposed to the proxy having what they think the customers need. So this is what Barry O'Reilly says also in his blog. He says, for leaders who manage for outcomes rather than controlling outputs, the shift to remote work, that's not a problem, because their natural focus is prioritizing the top problems. Here's the things you should pay attention to. We need to have, this next. We need to get this done so these people can have that result. So their natural focus is prioritizing what's the most important thing next, agreeing on how we're going to know that the customer is happy, and then supporting whatever outcomes the team produces that solve the problem presented to the team in a good way. And it's that kind of thinking about management that we need to think about learning from what's been going on in the last several months. I'm going to sort of shift gears here, and I'm going to show you something from a very interesting book called When More Is Not Better by Roger Martin. This is, believe it or not, a book on economics, and it just came out. It was actually completed by the end of January, but it's awfully relevant. I'll quote it again a little bit later. But in this section is something I'd never thought of before. He has a graph, and this graph is down here is the 4 quartiles of the kind of job you have, and up here is compensation. And the width of each box is how many people are in that, the range, the salary range for that job, okay? So now if we take a look, for example, back here is routine work sold locally. So what would that be? That would be store clerks. They do routine work, the stuff they sell, somebody walks in the store. Routine work sold locally would be somebody in a hotel at the desk. The stuff that they do, the result is local. The next one is other routine work. So routine work, but it's sold globally. So perhaps you have somebody that does, say, some outsourcing, and so it's the remote place tells you exactly what to do, but the result is a global result. Now, the salary range for the routine work sold locally in the United States, and this is in the year 2000, it's not now, it's like 2000, 20 years ago. The range there was from 10,000 to about, say, 32,000. And other routine work, the range was from about 18,000 to maybe $42,000 for that kind of work. If you happen to do creative work, but it's sold locally, like let's just say an architect who does creative work and their work is sold to the local companies. There you have, now if you look here, this says the percentage of the workforce that's doing that kind of work. And in this case, about 22% of US workers were doing creative work sold locally, and their salary range from down here is about 22,000 to about 61,000. And then there's creative work that's not sold locally, global creative work. And there you see that's only about 18% of the workforce, but the salary range was from 35 to 85. So that sounds like a cool thing. Now, what do we mean by creative work? In creative work, workers exercise meaningful, independent judgment and decision-making in order to do the job. And I want you to ask yourself, in your job, as a worker, do you exercise meaningful, independent judgment and decision-making? And do your colleagues, the teams you work with, does everybody on the team exercise meaningful independent judgment and decision-making in order to do the job? If we look at what went on in 12 years, so this is now 12 years later in the US, our routine work sold locally, the box, the red box, okay, the overall box hasn't shifted. It's just about the same as it was. If you look at the box for other routine work, this is routine work, but it's sold globally. And I would propose that if you have somebody that's telling you exactly what outputs they want, you're basically not doing creative work. That's about 20% of the workforce, and its salary ranges from about 20,000 to about 45,000, maybe 50,000. And it gets a little bigger. You see that little black stripe there? That means there's a fewer people and they're getting paid a little bit more in 2012. Here is creative work sold locally, okay? There are more people doing it and they're getting paid actually up to about 70,000 now in 2012. And those people doing other creative work are being paid up to about $100,000. But there are only 12% of the workforce actually doing creative work that is not sold locally. So the question I have to ask you is, where do you want to be? I mean, I think we like to be here, possibly here. We want to do creative work. But if you want to do creative work, we have to stop talking about completing tasks that somebody else decides should be done and start figuring out how our job is to delight customers. So I want to talk about respect. By the way, this is in Talon, just, pretty close. And respect, to me, that means that workers solve critical problems without proxies telling them how to solve the problem. And I would like to see the way we think about developing software in this new normal shift from teams doing what somebody lists as the proper tasks and prioritizes to teams that figure out for themselves, what do they need to do to make the customer happy? How does this work with big software projects? Well, I'm going to just do a really quick summary of the responsible engineer model. It's the model that's used by, for example, SpaceX. SpaceX has a lot of software, but they don't have any software teams because they have teams that deal with the major components of the spacecraft. So here's a Falcon 9. Down here, that's the engine. Here's a payload, second stage. Now, if you are on any of these teams, you might be on a Merlin engine team, okay? And so you would be responsible for something on the Merlin engine. And if you happen to be a software guy, you would be working on some of the software needed to make that engine work correctly or to monitor the engine in case it misfires during flight, that you can figure out what went wrong. So there's a ton of software here, but there aren't software teams. There are teams for every component in this spacecraft. And if you think about it, from 1970 to 2000, the cost to put stuff in space was pretty expensive. A kilo cost about 18,000 US dollars. But when SpaceX decided that they were going to figure out how to make reusable booster rockets and make it possible to put stuff in space much less expensively, and it took them 5 years, it's 6 years, 7 years. If you've ever seen the video of how they crashed a whole bunch of these booster rockets while they were figuring out what to do, you'll see a different take on what it means to do good engineering. But in that period of time, and even with crashes, because they didn't take too much time to figure everything out, they had deadlines against which they tested things. The cost fell to less than $3,000 per kilo. So that's like a factor of 7 in that period of time. And right now there's just nobody that can compete. And they operate from a philosophy of responsibility, which is what I want you to think about. Their philosophy of responsibility says that engineers are responsible for the design and development of a component, all the engineers necessary to make that happen, and for making sure that their component operates properly and does its job as part of the overall system. So the team is responsible to understand not just what they should be doing, but what they should be doing as a part of the whole system, what their landing leg is supposed to do to lock that thing on the boat, for example, or whatever. And Maltroni, who's their launch director, says there's no engineering process in existence that can replace the philosophy of responsibility for getting things done right and efficiently and rapidly. And I think it's time for us to think about how to switch to that model. I'm going to go back and change gears again, and I'm going to talk about the next thing that we saw in the pandemic as it hit. And that was, we had these very efficient supply chains and they just plain collapsed. There was dramatic shifts in demand and they couldn't be accommodated. So for example, here, there was this big shortage of personal protective equipment. We couldn't get cleaning supplies, hand sanitizer, like soap for your hands, food. We had some food shortages and some we didn't. And the most interesting one around here was we couldn't get flour for baking. After a first month, the flour just got completely off the shelves. And the reason for that is because there's plenty of grain and there are plenty of mills, but there wasn't enough packaging supplies to package into consumer bags. Here we do 5-pound bags or 10-pound bags. And they did 50-pound bags for bakeries, and they couldn't figure out how to package the smaller packaging things and get them into the supply chain for months. By the way, infrastructure was much more resilient, and that's what we're talking about, resilience. And it was more reason. We had no problem with water, no problem with electricity. There was a few, but not too many. And we didn't even have problem with internet. In fact, we had high speed and it got faster. So we need to figure out, why is it that supply chains break? Because pretty much whatever you're doing, you're probably in some sort of a chain. Why are some supply chains resilient and some planes, like infrastructure, and some not? Okay, 2 reasons why supply chains break is the demand changes faster than the time in the supply chain, or the demand exceeds the capacity at some link in the supply chain. So the first one, demand changes faster than time in the supply chain. That would be your personal protective equipment. So the demand went skyrocketing, but it took, like, the supply chain was a months-long supply chain. It would be stuff manufactured, say, in China, put in a shipping container, go on a container ship, arrive at some port somewhere, go on a train, eventually get to wherever it's going. That's a long time in supply chain, and the demand changed like overnight. Or the demand exceeds capacity at a link in the supply chain, like flour in the US. The link in the supply chain was packaging, and it couldn't be accommodated. So those are the reasons why a supply chain breaks. Now, if you think about durable goods like appliances, okay, those supply chains tend to be slow and therefore not very responsive, not very resilient. We, to this day, have shortages of appliances because it takes a long time to get appliances built on container ships into our ports, for example. Perishable goods supply chains, however, are much more responsive, and we could learn something from how come our perishable goods supply chains are much better off. And infrastructure, basically the reason why it didn't collapse is because it's not designed for right now efficiency. It's not designed for current demand. It's designed for long-term. And almost all infrastructure is that way. So example, if you go to a local park and you see somebody planting a little tree, it's going to be like 25 years before that tree is nice and big and creating shade, but they still plant it. But we don't do that in our companies. We don't plant something hoping 25 years later that it's going to be a nice thing. Resilient supply chains that are in this area of a link in the supply chain broke. If you had a resilient supply chain, you have investigated every step of the supply chain, and you have some slack, some redundancy every place, extra capacity to package flour. And if you think about that in software, that's the same concept as loose coupling. So you loosely couple things and you make each piece resilient. Basically, loose couplings limits the blast radius of failure. So that's taking every step in our ability to make stuff in our chain of reactions in our software and making sure that each step has some slack, has some resilience. And now let's go to the infrastructure. I want to say something about this for supply chains. So loose coupling meant that there was a way to rapidly change packaging if it wasn't tightly coupled to the flour mills, but it was. Infrastructure basically is designed for aggregated maximum demand, and it doesn't usually have capacity problems. So here is the book again that I mentioned, and the basic premise here is that the relentless pursuit of efficiency has created fragile supply chains. Now, the theory has always been you should optimize the supply chain at every link and make sure it's very efficient. And basically, we tend to do that in making sure that we deliver our software with a high productivity, and we're counting just the software. So you want to think about this. In a supply chain, at every link, at the creation link, we pay low wages. At the transport link, we get big batches. At the distribute link, we go long distances. And every one of those lacks resilience. It's very slow, there's no redundancy, and there's strong dependencies. Now, we know this is not good in software, but actually this is not good, period. We have to figure out how not to have these kinds of things in the stuff that we're working on if we're going to have a resilient environment to live in. So I like to think about it this way. In 97, 99, Eric Raymond wrote a book called The Cathedral and the Bazaar. It was about how open source software is like a bazaar, and the standard at the time was great big architectures like a cathedral. And he figured a bazaar shouldn't ever work. Highly architectured software was most important. But then guess what? Linux worked, and it worked really well. And so he tried to figure it out. And he said, you know, there's an awful lot of good stuff in a bazaar model. You have an awful lot of different stations here, and each one is sort of an independent little station. It brings its own fruit, or it brings its own meat, or whatever it is that they're selling at the bazaar, and the guy right next to it might have the same stuff. And if one of them doesn't show up, doesn't matter, there's plenty of others. This is a very resilient way to distribute food, because and basically it's been around for centuries. You can see it in almost every country in the world. And there isn't a lot of planning, there isn't a lot of architecture, just a little bit of structure. This is one of the most resilient food supply mechanisms in the world. Let's think about how that works. So I want to talk about optimizing for speed rather than for resource utilization. A perishable goods supply chain optimized for getting stuff from where it's picked to where it's eaten as fast as possible. And the whole concept that we need to be thinking about in software is optimizing from when there's a problem to when the problem's solved as fast as possible. And I call that flow. And if you want to think about flow, think about it in terms of, vegetables. So here is a person bringing vegetables to a market. And she could, if you were optimizing for the most efficient way to get these things to market, you could have a truck, sitting in the fields and fill the truck up. And when it's full, you drive it to the market. But it would take forever to get full and get to the market. You don't ever optimize for, full trucks or resource efficiency when you have a perishable goods supply chain. You don't optimize for utilization. It doesn't make any sense because the food will spoil. You never accumulate large batches of stuff because small batches move faster. You aggressively discover and eliminate the biggest bottleneck, and then you do it again. And you use consumption. When people eat food, that tells you what to bring to the market the next week. And the feedback you get by what people are buying and telling you they want is what you use to decide to make to plant next. So I'm going to say something here that you have probably heard before, but I'm going to say it in a way that might strike you as a little bit of heresy. In Lean, we say don't batch and queue. Think about rapid flow, optimize for speed. And I'll tell you, in the new normal, we have to think hard about optimizing for speed. Don't batch and queue. Projects are batches. Backlogs are batches. Prioritization is an operation on a batch. Estimates are the ways we think about how to prioritize so we can get our batch organized correctly. Every one of these is a push system. They forecast demand. They do nothing when an event occurs and changes everything. In times of uncertainty, a push system is guaranteed to be wrong. Whatever backlog you had going into March 17th was certainly not the backlog you worked off of 2 weeks later. The concept in Lean is not to use a push system, but use a pull system. Understand demand and pull from demand. And again, I think in the new normal, we have to think really hard about how to be more responsive. And this is the primary technique of how to be responsive to demand from customers, from consumers. The way you do it, this is the how-to, is to establish a regular cadence, a regular pace, a regular rate at which you deliver stuff. And then you figure it out. I mean, you can probably go to your database right now and find out the rate at which you put stuff into production. You put items into production, the rate at which you deliver stuff. You should never, under any circumstances, accept demand at a higher rate. You don't put it on a backlog, you just say no. You know your delivery rate. If it's 10 things a week, you do never accept more than 10 things in a week, period. It doesn't make any sense, you can't do them. And you maintain a shortest buffer as possible between your accepted work and the work that you're actually doing. And that little buffer is to absorb variation in demand and nothing else. And you just maintain this short buffer of work and you do it and you make it happen. And yes, I agree, this moves you to a much more like a continuous delivery flow. But even if you're not doing flow yet, you can still do this. You can not accept demand at a higher rate than your output and maintain a very short, if it's short enough, it can be first in, first out. So you don't need anything more than a first in, first out buffer that's short, that's enough to absorb variation and accepting demand at the rate that output comes in. And if you get demand beyond that, you say no now. You don't put it on the list. I'm going to move on from that, but I'll be happy to take questions. People always seem to have them. Next came a recession, all right? And that basically disrupted everything. But I would propose to you that we know about disruption. We understand disruption in the technology industry. This is a picture of that's on, I guess I saw this book in the end of the last talk. This is the cover picture. Tom took this picture on May 25th, 2002 on a bike ride that we did in Sardinia with a little tiny 3 megapixel digital camera, his first. Tom had been taking pictures for years and he had, you can't imagine how much film, black and white and color. I've just scanned all of it. And this is his first digital camera. It's in 2002. And what happened after that is sort of the story of Kodak versus Fujifilm, because these were the two film giants in the world and they competed aggressively with each other. And here's what happened to color film demand. If you start over here, this is 1994. The peak is right in here. Right about here is when the picture was taken, okay? This is when Tom switched, a very good photographer, many, many years of film, switched to digital. And so did everybody else in a few years. And by 2012, there was no more demand for color film. It disappeared. But what happened to the two companies is very interesting. Kodak pretty much died and Fujifilm thrived. And Fujifilm thrived because they did something interesting. And they stopped putting money into film and they took a look at their assets and said, what can we do instead with what we're good at? And they ended up getting into pharmaceuticals and even cosmetics, because that's the same kind of chemistry that all of their chemists were good at. So if you take a look 10 years later, Kodak's revenue was down 48% because they couldn't sort of break free of the image market and thinking that they were in the image market. Fujifilm's revenue was up 60% from 2000 because they had shifted gears and gone a different direction. By 2012, Kodak had declared bankruptcy. So this is not unusual. We've seen lots of cases of this. This is a picture of United States. You know Netflix, yes, but you probably haven't heard of Blockbuster. Blockbuster was a storefront that had VHS and eventually DVDs, where you could go to the store and pick up a DVD and bring it home, pay a fee, bring it back. It was like a library. It was a lending library for video cassettes and eventually for DVDs. And actually, it had late fees if you didn't return them on time. So it was a storefront video rental. And in 2004, it had $6 billion in revenue. And it had a huge amount, about 3,000 storefronts in the US. And they charged late fees. So everybody hated those, and Netflix decided that they were going to do DVD by mail. And instead of late fees, they were going to have a flat fee subscription, 3 a month. You return one, you can get another one. And, as long as you had some, you didn't get a new one, but you could do up to 3 a month. So Blockbuster got rid of its late fees, but it was making so much money with those fees that was really hurting their bottom line. So they got a new CEO that said, oh no, we're going to have to have late fees. And they started doing DVDs by mail, just like mimicking Netflix. Netflix, about the same time, started streaming. They added streaming to their subscription. You could do 3 hours a month or 2 hours a month, depending on how much you paid for. Streaming was slow at the time, but it still was a concept that was a coming up, up and coming concept. So Blockbuster reinstated their late fees, made people even more annoyed. And then they also instituted a way to compete with streaming that you could go to your local store, maybe it's maybe it's 4 kilometers from me, and you could download movies at the store, take them home on a special chip. You needed a special reader at home and play them, as opposed to the streaming that Netflix supplied. As you can imagine, it wasn't very popular. That didn't work. So they added some more late fees to get their revenue up. And you can see what that did when they added these late fees here. Bang, they kind of lost everybody. And at about this time in here in 2010, Netflix started a streaming only subscription. So that's the story of a whole bunch of disrupted industries. But we know how to survive disruption. And those 2 stories I just told you give you a hint. First thing you have to do is stop doing what isn't working, period. You have to recognize it isn't working, and you just have to stop funding it, stop doing it. Stop annoying your customers. Hint, backlogs are a huge annoyance for customers. Preserve cash, all right? Because, it's going to be a long road here, and you have to be not spending cash on interesting stuff. It has to be the right stuff. So find some sort of an unmet need that you can use your existing expertise and assets to do something with, and establish short customer-focused feedback loops to help you figure out how to leverage that asset. As, for example, Fujifilm did with pharmaceuticals. And this is the motto that we always had at 3M: try lots of stuff and keep what works, because you don't know what's going to work. So the classic story is this: a pizza maker in Chicago that figured out how to toss face masks. They use the same equipment, same oven. They just put that thing in, a plexiglass in instead of a pizza. And they started making a few thousand plexiglass face shields, not masks, face shields a month rather than pizza. The workers, they were able to keep most all of their workers, and they were able to get enough revenue to survive until they could open again. So the thing, what we need to think about in rapidly changing environment is what I'm going to call maneuverability. These are two little impalas, and they are very, very fast. They might try to have some fights, but believe me, this lasts only a second and they're up again, because there could be a lion or a leopard looking for them, and they have to be very alert. So this is maneuverability. This is the story of John Boyd, who was a saber pilot in the Korean War, and he had to fight against Soviet MiG-15, a faster aircraft, heavier firepower, narrow turning radius. But in the end, the Sabres, the F-86 Sabres, did way better than the MiG-15s. And he wanted to figure out why. So he studied all of the different aspects of the different planes, and he came to this conclusion, which I think is an important conclusion. The F-86 Sabre's success was a byproduct of its ability to transition from one maneuver to another faster than the competitor. And I think that's what we need to learn how to do, maneuverability. Can you switch faster than somebody else from one way of doing things to another? This is John Boyd's maneuverability loop, or OODA loop. It's observe, orientate, decide, and act. It's a classic learning loop. I mean, in Lean, we often call PDCA, plan, do, check, act. This is very similar concept. And I want to show that he talks about observation and decision and action, but the important part is this part right here of orientation. And in orientation, what you're trying to do is you take your existing mental model of how things should be done and you update it to make sense of the way things are changing around you. Things are changing fast. And you need to think about, how do I quickly update my mental model to make sense of what's going on? And you have lots of things. You have cultural traditions, you have genetic heritage, you have previous experience, you have new information. You put that all together and you analyze it, you synthesize it, and you come up with a hypothesis here of what you might try. And then you do it and see how you test it, see if you're right. And if that doesn't work, you try something else. So it's this OODA loop that I would like to place all of our development teams into, so that the team is engaged in this entire loop. So if you think about that, you want to think about a small, diverse, responsible team doing the orientation and then making the decision and the action. The reason it has to be small is because it has to be fast. The reason it has to be diverse is because it has to have lots of ways of looking at the problem, not just one or two. And the teams have to be responsible for the end results, as I talked about responsible teams on the SpaceX environment. So if you want to solve for maneuverability, which I think is a really fundamental piece of resilience, you need this book by Jeff Seiden, Jeff Gothep and Josh Seiden is a really good book about sense and respond. Create an environment where teams sense and respond. You need to maintain a continuous two-way conversation with the market. In order to do that, you need small, multidisciplinary teams. And that team is not a DevOps team even. It's not a software team. It's not a technology team. It involves everybody that's involved in delighting the customer. It involves folks from marketing. It involves people who, it involves everybody you need to solve the problem you're trying to solve. And that team has a clear goal. You need to make sure that all the professors know how to use this new tool or whatever. And the goal is they have a defined outcome. When this happens, when these customers are delighted and are able to shop better and we get more customers at our grocery store, that's success. And they have to know the constraints. If you have only 3 days, you have only 3 days. And those teams have to be able to act asynchronously and without permission. And asynchronously means they can't have dependencies on other teams. And without permission means they don't have to get permission either from other teams or from management. This right here, this is almost always in software an architecture problem. It's a dependency problem, which is an architecture problem. And if you have it, it's the best thing to do is to attack it. And this team should be responsible for building the right thing, using the philosophy of responsibility that I mentioned. And they should have frequent delivery to customers, frequent. If you're online, it should be daily or more. 2 weeks in 2020 is really, really slow. They need to figure out how to learn their way forward by deploying something, seeing what the results are, making sure they can measure it, and then trying something else. And success is the outcome at the customer site. Is the customer happy? Are they delighted? Is their shopping problem solved? Can they teach online or whatever it is? We shouldn't be worrying about, do we have the test done? Do we have proxies like business happy? I don't think so. I think we should be moving now in this new normal to whole teams that actually solve customer problems. So I would say the new normal is this. Resilience is more important than efficiency. We need to be able to figure out how to give responsibility to everybody on the team and have them responsible for making decisions. We need to have high maneuverability. We need freedom to act asynchronously and without permission. And we should pull from demand. We should manage by rate. We should have short, first in, first out queues, if we have queues at all. And that's about it. So with that, I want to say thank you. And I think I'm just 2 minutes over my time. So I'll turn it back to you and you can decide what to do next.
Thank you, Mary. I think I have to make this joke because it fits the remote environment very well. Is this background that you're using, is it a virtual background that is video where Tom is just working, or this is real?
Wave, Tom, wave.
Hi, Tom. I had to make this.
Well, the pictures on the walls are virtual because those are his.
Okay. I also.
But it's a real Tom. Yep. Because if anybody has questions, I know there's not time, but he'll scoot up here and help me answer questions when I have questions. So that's
really cool. I was also very happy to learn that Tom actually made an impact in. Of course, code in the history of Kodak bankruptcy. He took a picture and then everything started to fall down. Okay, so
that was it. No more color film for him. All of our digital photos are nicely dated just after 2000, so we can use 2-digit years.
Right. Now let's get a bit more serious. I really enjoyed your take on the new normal, and I also took some notes while you were speaking. The last one I took actually is 2 weeks in 2020 is really, really slow.
Oh, yes.
I'll just leave it there. But we also have a few questions from the attendees, and let me start with the ones that collected most votes. The top ones actually are very similar. They're asking about the same thing. I think the proxy topic triggered a lot of thoughts with lots of people, and those questions are about proxies. So let me just combine them together. So the first question is how to avoid proxies in scaled environment. Or I will take another sentence from the second question. The question is about how to make the cultural shift in the environment where we have lots of people, like let's say plus minus more or less 150 people, 20 cross-functional teams working on one product, or let's say it could be multiple products, it doesn't really matter. But how to really, where to start with these proxies, how to eliminate them.
Okay, so I think I really put that picture of SpaceX up for a purpose. You need to start by changing the organization, thinking about systems engineering, where you think of what you're trying to do, if it's big, as a well-defined, connected series of loosely coupled subcomponents. That's exactly what a spacecraft is. It's what an aircraft is. And it's what a car is. Anybody doing very large scale projects that require a large amount of software, they start by dividing the physical thing they're trying to deliver into chunks of components that can be turned over to whole teams. Now, in any of these things, there's usually a chief engineer at the top, and there's sub-chief engineers for each component. And the sub-chief engineers work with the other sub-chief engineers to make sure there's well-defined interfaces. But fundamentally, it's a cascading thing where you have chief engineer, sub-chief engineer, and then some, maybe, for example, take Falcon Heavy. It's got 3 Falcon rockets. Somebody has to care about all 3 of them as a booster. But then each independent Falcon rocket has its own team because it's, a separate booster. And it has 9 Merlin engines on it. And those 9 Merlin engines, there's a whole team that does nothing but 1 Merlin engine. And then you put 9 of them in a Falcon 9, and then you put 3 Falcon 9s on the plane. And so every single subcomponent knows their role in the whole picture and what they have to do. It gets defined because there's a launch date in 3 months. And in the launch date, this is the goal that we have to achieve in 3 months. But those teams they don't have software, and they don't have fuel engineers, and they have a team to do a Merlin engine, a team to do a Falcon 9, a team to do a payload. Each team contains the necessary engineers to solve that component's problems. You have to start with that structure, okay? And it's definitely a possible structure, and it's a classic engineering structure for large systems. It's not like you can't do a large system. There are other structures. So if you take a look at AWS as opposed to SpaceX, AWS has an amazing number of separate teams, and they have extremely loose coupling between the teams. And a service is so independent from other services that basically a service might have 3-4 teams, but that service is very much an independent item, and they have a whole flat array of services. AWS puts approximately 300 new services on the market every year for the first 10 years of existence. That is like 1 a day. And a service will have a team. And that team doesn't just include software people. It basically is usually led by an entrepreneurial leader, a sort of mini CEO that's responsible for a particular deliverable on that service, which is customer focused. And then they have ops people, and they have development people, and they have test people, and they know what their role is in a bigger picture, and they know what it means for their service to work well. And they're divided into services, again, architecturally, and they created the architectural concept that you have APIs that are hard, and you can't go underneath an API. There's no tight connections between services. They're all connected with a contractual API in between. If you have that architecture, you can have independent teams. If you have a system architecture of cascading components, you can have relatively small independent teams. But if you don't have one of those 2 architectures, it's hard to get started. I think most of the time you have to think about, how can I fix my architecture so we can have teams that are sensible size that attack problems?
The key to having the architecture work is to have your metrics work, to have how you know you are successful be the thing that matters. In the case of SpaceX, getting a payload into orbit for a low price by being able to land the components and reuse them is what success is. If you don't achieve that, nothing else matters. You have sub-teams who worry about the pieces, as Mary described. And you have to work together with the other sub-teams to achieve the low-cost insertion of payloads into orbit. That's the only thing that the customers care about. So you have to think about your team as everybody that shares the top goal. The sub-teams are not measured separately if they don't contribute to the overall objective. The key thing is they have to work together effectively. And that's not a matter of scaling. It's not a matter of process. It's a matter of shared attention to the overall success.
Thank you both. Thank you both, really. We have another rather provocative question, and we can probably be short about it, because I think you had an answer in your speech. But let's just get to the question. So the question is about we had waterfall as a paradigm time ago, where we had big projects, big teams delivering big outcomes in the big batches. Now we are in more agile, lean environment where we still have where we still focus ourselves in. And I'm rephrasing the question, by the way. So, lean environment, also focused on waste elimination, but smaller teams, of course, smaller batches. So the ultimate question: what's the future? Will we have a one-person team and some, like, I don't know, micro batches or something like that? What's your take on it?
Okay, well, I actually think that AWS is a really good model for software, because they're massive, but their services are relatively disjoint and relatively small, and their teams are, to this day, they're the classic 2-pizza team, which is a team you can feed with 2 big pizzas. And they may have a couple or 3 teams together on a service, but they don't have big big things. But it's not one person, okay? Because one person can't do all of the, we live in a deeply technical world. This is the stuff that we do. One person can't know all of the different ways that you need to think in order to do a good service, because there's so many different concerns between security and you need lots of different kinds of expertise depending on what you're trying to do to be able to pull something off. The idea that a single person would have the background to do that, I think doesn't give you a lot of leeway of all the interesting things you could work on, right? Because nobody at SpaceX is going to be able to do mechanical engineering and software at the same time, not really. So I've worked on teams. You don't want them to be one person. You want them to be, Netflix tended to have 3 or 4 people on a team. Amazon tends to have 10 or 15. I think it depends upon the context. But there's a right size team, and it's the team that you can bring all of the expertise together from different competency areas to accomplish some problem solution. And you need to have a systems engineering approach or a service approach that allows you to divide up so that you don't have too much together. And hopefully your teams, you might have sub teams, and in bigger teams, but on any smaller team, you tend to be in the vicinity of less than a dozen. And in a bigger team, I've often found for products of the size I've worked on when I was at 3M, we had teams in the 35 to 70 kind of range. And they were sub teams of different expertise areas. So no, I don't see a team of one. You never see a startup company stay one person. There are a few, but not many. They always get a few more people. Maybe they don't get really big, but there's too many different perspectives on life. And here's the 3 perspectives I think are the most important. You need to have somebody that understands whatever technology you're trying to do. You need to have somebody that understands design. That is, what is the customer experience and how can we make the experience really good? And you need to have somebody who understands how to bring this thing to market, how to get money for it, how to sell it. And if every good product they've ever seen has somebody, maybe 2 people, sometimes 3 people, but at the leadership of every group of really successful products is a triumvirate of skills, which are good tech skills, good market skills, and good design skills.
I don't think team size is a critical dimension. The shift, as we went from waterfall to what we call Agile, is not primarily about team size. It's primarily about a shift from push, somebody else telling people what to do, to pull. The people who are engaged in solving a problem figure out the problem and determine through experiment what good solutions are. Now, the number of people it takes to do that, if anything, it might grow because the complexity of problems that we are attacking keeps growing and growing. The domains not just require software, but they require multiple professional competencies in order to come up with excellent solutions. So if anything, the teams might grow. As Mary just suggested, when you're building a product, it takes more than software. It takes many, many areas. And that could be 60, 70 people, could be 600 people, depending on the particular problem. But
that's probably enough. Cars can get done in about 600 or 700 people.
The key thing is that the people solving the problem figure out what the real problem is and decide themselves what the solution is. It's a matter of autonomy of the team, not a matter of size of the team. The biggest waste is always not mechanical waste, but building the wrong thing. And most often the waterfall led to building the wrong thing. Push in Agile, having external people tell the team what to do also results in a lot of building the wrong thing. The shift today with the DevOps movement, the very rapid iteration, the instant feedback that is possible in some fields, leads to much more rapid discovery of whether what you're working on is right and the ability to maneuver and change your direction so that you invest most of your energy in things that actually make a difference that you care about and your customer cares about.
Okay, thank you very much for that answer. I have probably one last question that looks very interesting personally for me. And it doesn't necessarily have to be about the tools, because the question has the tools word in it. You can extrapolate in the way you want, but
okay.
The question is the following. What tools would you advise to use instead of backlogs and prioritization to deliver delight to customers?
Okay. I did say it. I don't think it came through, but the tool to use starts with a continuous delivery. Okay, so you do not batch stuff into 2-week batches. You have a continuous delivery technical capability. The second thing that you do is that you create a way to deal with demand. There's always more demand than you can deal with, always. But you have like 3 bins, now, next, and never. So when you get a request to do something, or there's some way that demand gets sent at you, you immediately say, no, I actually don't have the capacity for that. I'm sorry. Maybe I could help you find another solution, but I can't do it. You say it right away because you know if you have the capacity. You also, because you have this short buffer and it's first in, first out, you also know that if you accept it, you can also say yes, and it's going to be done in 3 weeks, because you know how long your short first in, first out queue is going to get, because you're doing stuff at the rate of like 10 every week, and this is your 30th one. Let me just give you an example. I was talking with somebody who was writing articles for a website, and she was interviewing us, and she was about to interview Woody Zoll. And I said, oh, the no estimates guy. And she said, yeah. She says, I don't understand. She wasn't a software person. I don't understand this thing about estimates. I just talked to Kent Beck. And he says, well, I never use estimates. I kind of don't know why. And I kind of do. So I said, okay, so let's try something from your experience. How many articles do you write in a month? And she said, 8. And I said, would you ever accept 12 articles? She said, no, of course not. She accepts 8. And she might be out 6 weeks. That's it. And when she doesn't have a slot, she says no. And she has complete control over her flow. And she doesn't think about prioritization. She might have a spare spot in case a really attractive one comes up to her and she'd really like to write that article. But she does not have to do prioritization or estimates or backlog or anything. And we don't either. We can have a regular rate. We do 8 a month, 18 a month, whatever. We have a backlog that's 6 weeks long. We can do everything in 6 weeks. So when we get something, we say yes, and it's going to be done by bam. And or we say no, and we don't wait to do that. To me, this is so much more transparent, so much more honest. Not only are we telling our customers if we can do it or not, but we're telling them when they can expect it to be done. And if you are working at any kind of pace, you can do this. Now, if you have bigger projects, the mechanism is a little bit different, but it's pretty much you always manage by how many per unit time you can get done, and you don't accept any more, and you make the buffer really short as you possibly can. And then you accept and you deliver, and it's fresh. You're not going back and saying, you know, that thing you asked for 6 months ago, do you still want it? What's the changes? You don't waste your time with that. All of this backlog and prioritization is waste. It is not necessary. It can go. You just have to figure out how to quit having it, have a very short queue, and either say yes or no, and actually promise date the day you get something in. Think about our writer. If she can do it, why can't you?
True, true. Okay, everyone. So on behalf of organizers and all attendees, I'm pretty sure I can say we were absolutely thrilled to have an opportunity to have you here in our conference. Really, really great. A lot of great ideas, and I think a great Q&A session as well.
Cool.
So thank you very much, both of you. Hopefully, we're gonna meet soon on some other Agile tours coming next years. Yeah. And with this, I want to say that we're going to conclude the conference today, day one, with some feedback session with all the attendees. So once we conclude the session with Mary and Tom, we're going to go ahead and unmute all the attendees. So if you want to say what you liked on the during the day one, just unmute yourself, tell us. If you want to share any other type of feedback, go ahead and do that. So again, thank you very much. I'm switching now to the feedback session with everyone.